Good afternoon, this is Kavi Priya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the case study topic MRI Technology and Electromagnetic Fields from the subject Electromagnetic Fields and Waves. This is my flow of presentation. I am going to discuss about the introduction part, what is the principle behind this MRI, real life case, role of electromagnetic field in MRI, advantages, challenges and limitations in MRI, and finally the conclusion. First, what is this MRI? MRI is a magnetic resonance imaging. It is a medical imaging technology. It is more widely used for producing a clarity image of the human body parts. So through this, doctors can easily detect the diseases and provide a treatment based on that. So compared to X-ray, the radiation in case of this MRI is very less. So what is a basic foundational for this MRI, which is nothing but it is an electromagnetic field. So what is the principle behind this MRI? So it works on three basic electromagnetic components. First one is a magnetic field. MRI will be generating a strong magnetic field in the range of 1.5 and 3 Tesla. And next one, there's a radio frequency wave, and the machines will be sending this radio frequency wave into the human body. And third one is that electromagnetic waves will be detected by the receiver coils and it is processed by the computer to provide detailed images which can be used for identifying the diseases. Real life case. For example, if you are considering a patient who frequently undergoing headaches and dizziness, so initial examination, based on the initial examination, if a doctor wants a patient to take a MRI, what is the procedure behind this MRI? First thing is that the patient will be lies inside the MRI scanner and the strong magnetic field will be produced which aligns hydrogen atoms in the brain or tissues. And third thing is that RF pulses are applied to disturb this alignment. The emitted signals are collected and it will be analyzed. So this is the process behind this MRI. What is the role of electromagnetic field in this? So it is a basic and fundamental for this MRI operation. Static magnetic field first is created, which aligns the hydrogen nuclei, creates a basic condition for imaging. Radio frequency electromagnetic waves will be exciting this hydrogen nuclei, which causes the energy absorption and emission. And next is gradient magnetic field will be varying the magnetic field strength, determine what is the exact location of a signal, enables the cross-sectional imaging of a particular human part. Next one, what are all the advantages, limitations and challenges behind this MRI? The main important advantage is that it has an excellent image quality and also the radiation is very less when compared to X-rays. So the patients will not get affected by the radiation that is being emitted. And thing is that we can easily detect the diseases in early stage itself, and multiplane imaging is possible. Cross-sectional, for example, if MRI has to be taken for a brain, then using this multiplane imaging, the cross-sectional areas even it can be captured. It is divided to number of planes and each and every area will be captured independently, which will be very much useful for analysis purposes by the doctors. These are all the advantages. The limitations and challenges are that it has a excellent image quality, that is the main important thing. And the important limitation is that the patient has to be lie still for during the entire process. That is being the very important drawback of that. And there is a chance for the patient to get affected by stray magnetic effect as well. Finally, the conclusion is that MRI is an excellent example of the practical application of electromagnetic fields in healthcare. So by combining this magnetic field and electromagnetic radio waves emitted by electromagnetic waves, this MRI can produce a detailed images of a human body, and this electromagnetic fields plays a significant role in behind this MRI generation. And this is a summary what we have discussed so far. We have discussed about this MRI. We have discussed about what is the basic principle behind it, and what is the role of electromagnetic fields, what is a real life case, and what is the advantages and drawback. The main drawback is that it has a long scanning time, and the patient have to be lie still, and it is a high cost. And also when the patient wears a metal, it will be there is a restriction behind this. The patient, if a patient wears a metal objects like that, it can't be easy. So during the MRI process, it is not allowed. So the major drawback is that. And we have discussed about the final conclusion as well. And these are all my references. Thank you.